Okay, so we are talking about centripetal force and centripetal acceleration, and I think we're going to talk about Okay, so centripetal acceleration is going to be acceleration towards the center of a circle. So again, we're making simplifications. This is basically a first course in physics that uses math, and so we're making before when we were talking about acceleration, when we talked about straight line acceleration, in basically everything that we were doing before, we were basically talking about a change in speed. So everything that we were doing before, we were basically talking about changes in speed. And so if I'm going to get into vectors, you know, everybody goes, oh yeah, I got to remember that direction thing, because vector is a speed, and so velocity is a speed and a direction, and yeah, we got to remember the direction. But it's not a yeah thing. It's really, really important. Velocity is speed plus direction. Okay, so in the previous stuff that we were doing with acceleration, we were talking about changes in speed. Now, but acceleration is a change in velocity. So what we're going to do now is we're going to leave the speed the same, and we're going to change the direction. So circular motion So we're going to do circular motion where we're going to have a constant speed, but we're going to change the direction. And so that change in direction with a constant speed, that is going to give us what we call centripetal acceleration. And so the big equation that we have on that is going to be AC equals V squared over R. So it's going to be velocity squared divided by radius of circular motion. Radius of the circle that it's going around in. Okay, now we also have this idea of centripetal force. And so we're going to have F centripetal is mv squared over r, but I don't really like that. I'm not a big fan of that equation, because I want to have, in this class, I want to have as few equations as possible. I don't want to have, there's some places that they're just going to heap equation and equation and equation on top of you, and a lot of them don't have a lot to say beyond very specific circumstances. So this equation, I actually want you to think about this as two more fundamental equations. This is a fundamental equation, AC equals V squared over R, and then what's the next one? Think about it for a second. F equals MA. So this one's important, this one's important. Centripetal acceleration is V squared over R. Force is mass times acceleration. You put those two together and you get that centripetal force is going to be mv squared over R. So just a little note there. Then the next thing that I want you to, another reason why I don't like centripetal force is it is not a real force. Okay, so Fc is always the result of okay, Fc is always the result of adding together real forces. So we're going to come in just my next video or two. We had my little mass attached to a string, and it was going around in a circle. So I had a mass going around in a circle attached to a string. Well, there's a centripetal force this way. That's my Fc. But that's not a real force. What's the real force is there's tension in the string, and there is the force due to gravity. And these are real, so this is real, this is real, and this one right in here, that's just these two added together. That's just these two forces added together. Now, also at the same time is if I have a road and I've got a car on the road, there's going to be a centripetal force that allows it to turn the corner. But again, that centripetal force is not a force all on its own, it's a force that's caused by something. And so in the case of the road, that force, Fc, is the result of friction, gravity, and force normal. Okay, so three forces that you sort of all put them together and you end up with that Fc. Okay, so in the next video I'm going to get back to what I did in the previous video, and I'm going to analyze this motion.